Hey everyone, Matt here. A couple of quick notes before we get started. We have decided that for our next book, we'll be reading The Design of Everyday Things by Don Norman. So feel free to pick that up and read along with us if you're interested. The second is that with all of the holiday activity, we haven't been able to record for a little while. So this is one from the vault from before we had settled on our kind of book reading format. We're going to be getting back to the art of game design soon, but I hope you enjoy this little nugget from the Switch Statement Archives. Hello again, John.
Hello.
Are you ready for the first named episode of Switch
Dude,
Statement?
I'm so ready.
The podcast that we've finally figured out the name for.
It's the best name ever.
only-
Switch Statement.
Only 3 episodes in. That's pretty good, I think.
Yeah. But there's got to be a precedent for that, like a podcast that just can't think of a name for a super long time.
For multiple episodes. But we've got it. We've got our house in order. Welcome everyone to Switch Statement. It's a programming, a podcast all about programming. So we're happy to have any listeners aboard. So today, I think in light of the fact that we have found our name, we are going to do a deep dive on switch statements and also kind of their super powered cousin match or pattern matching or match statements.
Switch Statement,
What do
the
you-
most interesting statement in programming.
Yeah, no, I think that's true. But the funny thing or the joke that I was making is like switch statement actually sounds like a much more interesting name to someone who doesn't know what a switch statement is.
Yes. Yeah, it has the highest, like, awesome name to, like, fairly lame, I would say, actual reality.
Right, exactly. So, so yeah, I think for this kind of first portion, we can kind of dive into vanilla switch statements, talk about some of the history there, and then maybe kind of in the latter half, we'll dive into the crazy shit you can do with pattern matching.
Nice.
So yeah, just to start off with kind of like the ancestor to a switch statement, you kind of have to look at assembly code where you a regular operation is you say, okay, you have you label a line of code for in your program, and then somewhere else you can say, okay, jump to that label, right?
Yeah.
So that's kind of step one. You that would enable you to do some sort of like looping or what have you. And then step two is now you can say, okay, jump only under certain circumstances. So you have a jump if this one register is equal to some literal.
Right. So you could
And
do like a while loop.
yeah, so jump while this register is greater than 0 or something like that. You can continue to jump to the top. And with those two structures, you have enough to implement a primitive switch statement, essentially.
Now, when you were learning programming, I'm just curious about this. Did you even learn like labels and go-tos in your curriculum?
No, there were definitely no go-tos. I think they talked about it conceptually, but they never were like, hey, write this program using go-tos or anything like that.
Yeah. I just remember when I got my first job, it was Java. And I guess Java has like labels and go-tos. Like, I don't know like what they're,
It doesn't work though. It doesn't, you can't, like, go-to does not, it's a
it's a
reserved
reserved
word,
word, but it
keyword.
doesn't do anything.
It doesn't do anything as far as, and actually I learned that from you at Google when I had just started. So
Yeah. But I think I just remember people at my first job, talking about how labels and go-tos were this massive anti-pattern, because it's just not like it's not readable. Like you can literally just jump to any part of the code. As a reader, you can't like follow the flow of the code.
When I was at Google, there were definitely these kind of internal PSAs where they would show you, hey, here's this situation under which a go to completely or just like really enabled this very hard to see bug.
Yeah.
But it's interesting because I actually recently read a fairly aggressive defense for go-tos, which is it enables this pattern where you say do thing A, do thing B, do thing C, and then you can, if there's an error, you can kind of jump to different like step unrolling uh,
Yeah.
things where it's like if you've only gotten past A, then you jump to like undo A.
Oh.
But then if you've gotten to B and something fails, you jump to undo B and then it undoes B and then undoes A.
Oh, interesting.
And if you get into C and something fails, you jump to undo C, it undoes C, it does undoes B, it undoes A. And that's actually a fairly uh, difficult thing to write if you're not using
Yeah, I feel
GoTo's. Like
like
I'm not sure how.
maybe like I don't know. I see cases like with exception handling where you literally have like all these nested like try catches and stuff, and it's super ugly. And that actually feels like a somewhat more elegant way of doing that sort of thing.
I have to admit, I was kind of sold for that case. I've never had to write code where there was this stepwise undoing, but
I'm glad you mentioned this case because this is what I was just about to say is like, I remember being told that as a young, developer, and I was just sort of believing everything I heard. But I never, like, I don't, it's never been, totally sold to me, especially now where I feel like I'm much more open-minded about like, there's no hard and fast rules in programming. I always assume whenever anyone tells me that something is an anti-pattern, there might be some use case where it actually makes sense to do it. And it feels like there
right.
definitely is with labels and go-tos.
It's probably the case where someone actually had a fairly good reason to do it in the first place. And then someone else read it and didn't fully understand why that person did it in the first place. Did it in a bunch of different cases where it wasn't a good
Yeah.
fit. And then everyone's like, what the hell? Why is everyone doing this thing that doesn't make any sense given the context? And then that kind of like washes out the original, like reasonable way that
Right. It's definitely
you
something
should do it.
that feels like it can be really misused. So maybe that's
Yeah.
why, people just say there's a hard and fast rule. Anyway, I feel like I'm totally
Feel
sidetracking.
what can. No, that's all right. That's what this podcast is all about. This is what editing is for as well. So, so yeah. So even in the assembly, we have this primitive ability to write switch statements, essentially because you just say, if this value is equal to whatever, jump to this other thing, and you immediately have this switch like functionality where, and then at the end of your case block or at the end of your label for the real thing, uh, or rather, to use the terminology of the assembly code, you would just again jump to the end of the switch statement and then continue execution of the program.
Yeah.
So I actually spent a decent amount of time trying to find the first programming language that introduced a formal switch
Ah.
construct. And first I was like, oh, Fortran. That was kind of one of the first, or if not the first, higher level, on top of assembly language. And they have something called the select case. You say select
Yep.
case, and there's cases, and you're like, okay, job's done. I figured it out. Fortran, first programming language, it has select case. It's not that simple though, because they only added it in the 1990 version of Fortran.
Oh.
So, which presumably by that point, some other language already had switch statements, or at least you could imagine that they're at that point, Fortran is borrowing from some other programming
Right. Like when
language.
was C introduced?
That's what I looked at next, and it was harder for me to tell when specific the Fortran Wikipedia page was very clear about which reserved words were introduced in which versions, which allowed me to know when select case was
Yeah.
added. C, I guess maybe C is more complicated, but they're less explicit. So I don't know. I think they would have said it if it was in one of the like early KR, like Kernighan Ritchie versions of C, but it wasn't clear at what point they actually added it.
Interesting. Okay.
So this is kind of an unsatisfying end. I want to, because I think essentially what you need to do is start reading these legacy versions of these programming books and see if they talk about having a switch statement.
Yeah.
So no actual resolution there, but at least 1990, we know that probably most programming languages were using.
It would be interesting to know, the rationale behind introducing a switch, because I've heard a lot of people talk about how there's just a decent amount of sort of redundancy between a switch and like a classic if else. Like a switch is definitely like, there's more brevity with expressing certain things. But like, Python, for instance, like Python doesn't have a switch, right? And I think their
Exactly.
big argument is just like, you can just use a chain of if else's. Like, why would we include this like completely redundant, construct? Which,
Yeah,
yeah, sorry, I was just going to say, I don't necessarily agree with them, but I also don't like strongly disagree with them. So I would be interested to know the original rationale for like including this new construct that's, pretty similar to other constructs.
it's interesting because I remember exactly what you said, where the rationale for not including switch statements in Python was elifs, which that's, if you're not familiar, the way you write it in Python is you write if, case, whatever, and then elif, and then other
Which I
expression.
hate.
So, which is kind of crazy in a way for such a mostly elegant language. Elif is like, it's really the elf in the room. But
Oh my God. That was great, dude.
oh god, I feel ashamed. Don't worry, everyone out there. I feel as much shame as I should right now. So yeah, but the but essentially, I was actually reading the PEP, the Python enhancement proposal for Switch, and it actually, the rationale was more like there wasn't enough demand, or at least he kind of pulled the audience at PyCon, and he was kind of like, is this valuable enough to add to the audience? And he said add to the language, and ultimately he said there wasn't enough support for it to go through.
Wow.
So
Yeah. I mean, that's a good reason. Democracy, I guess. It is
right.
interesting though, because Switch, can confer certain benefits. Like, a huge one might be like exhaustiveness, which if you're talking about like a big code base, maybe you have like some big enum and, someone adds a new value to the enum, like every, every situation in the code where that enum is being looked at, you're probably going to have to like add this new enum. And with a switch, you can actually have the compiler, determine whether or not it's exhaustive, which is kind of nice.
Which, in a way, I guess for Python, presumably you couldn't do that anyway, because someone would just like add a value to the enum at runtime, and it all goes
Yeah,
out the window.
exactly.
So, so yeah. So the next thing I want to talk about is the idea of structured versus unstructured switches. So you talked about it being kind of a generalization of an if else, but kind of as I alluded to at the top, in C flavored languages, it's actually more of a generalization on top of go tos than if else, because of the way fall throughs work.
Oh,
So
right.
for anyone who's unfamiliar with the way kind of switch statements work in C and kind of all of its tributaries of languages, Java, C, C++, JavaScript, all of, I think most people are actually going to be more familiar with the idea that you need to break out of your
Common
case
bug, yeah.
in order for it not to kind of proceed on to the next case statement. And that is what is referred to as an unstructured switch. Whereas there's a whole other class of languages which which are called structured, and they are truly a generalization on if else's because they have the semantics that you can only go through one. You go through exactly one branch of the switch.
Oh, you know, I didn't know that. I did not realize there was like that distinction. But that it's
Yeah,
interesting because I hate, well, hate is a strong word, but like I very much dislike when people rely on fall through in a switch. Like if I'm reading code that doesn't have breaks in your switches, like I think the code is buggy.
is a
Yeah,
bug.
like I think you messed up. So if you're like relying on that, at least in my opinion, it feels like a massive code smell. So you're saying there's languages that actually like enforce that you can't do that.
Right. Yeah. So there's two flavors. I think I forget what the what the one language was. Let's see if I can figure this out quickly. Um, it's Pascal. Pascal's switch statements, and like I guess in that kind of branch of languages, they enforce only one branch. But then there's also this other kind of in between, which are languages, I think Perl and Bash, they allow you to fall through if you want to. You can use the continue keyword to continue on to the next switch statement, but
Oh,
they don't by
I
default,
like
which
that.
actually I think is a really nice in
Yes,
between.
yeah, because I was just gonna say, like, I don't want to retract my last statement, but I was gonna also say that I'm sure there's times where falling through makes sense. But I love that continue thing because it's signifying, you know, the developer is signifying like this is what I want to happen. Like this isn't the bug.
Right. You're being explicit about, okay, there's this thing that you wouldn't assume would happen, but it is happening and you can see it in the code that
Exactly.
it is.
Yeah, which is kind of the best of both worlds because, you know, you have the ability, but it also doesn't feel like a bug if you're reading code.
Right, exactly. So yeah, I know that in Google the rule was always you can fall through, but only in the case of an empty block. So you could say, okay, these five enum values, they all do the same
Yes.
thing. So you can say case, 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 and strictly speaking, it's a fall through because it's just an empty
Right. Yeah.
label, which I always saw the
Yeah,
rationale
that one
behind.
makes perfect sense. I like that. The case that I really dislike is where you actually have executing code in a case, and then that falls to the next case, which also has executing code.
Which actually, to C Sharp's credit, that's how their language works, where that's just you can either have an empty case or you need to break at the end of it.
Oh, nice.
So another interesting thing. Although I don't like that resolution quite as much as the continue because it feels like at that point you're kind of just like hacking your way back into a structured a structured
Right.
switch.
Yeah, the continue really does. I was, once again, I was completely unaware of this, but the continue really does feel like the best way to handle it. I like it.
All right, let's implement something cool in Perl. So, all right, let me. So I think that there's some interesting language specific uh, functionality for that that you can do in certain languages with a switch. So the first is, and it's like kind of gross, but it's also like okay, that's kind of an interesting spin on switch statements. Is what I like to call the inverted switch statement, which in this is in PHP. What you can do is you can switch on a constant, and then you can have variables in your cases. And so essentially the way that it would work is you would say, okay, switch on true, and then you'd say case variable, 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 and then the first variable that was true, you would execute that.
Whoa, that's crazy.
Which, again, it's like, okay, all right, it kind of makes me nauseous, but it's impressive. Good on you, PHP.
Yeah, anywhere, any language where you can just say like switch true, or any situation where it would make sense to say switch true just feels weird.
I'm wondering now, but this is the thing. It's like it's all about your tool chest, where it's like when you're solving a problem, you're going to kind of use the things that you've seen before. So now when I go about my program, my daily, yeah, I don't know, engineering, I'm gonna be wondering like, oh, could I switch on true? And
Yeah.
do I need to only do something if like several? Because it's kind of like it's like a precedence thing where it's like, okay, in this circumstance, there's like several things that could be true, but only one thing should happen.
Right.
So
Yeah, I feel like every time I think, oh, that's a terrible idea, like a couple days later, I come up with a case where it actually would work really well.
right. And so Ruby does something cool that I wish I could do, where you can assign a variable to a switch statement.
Ah, yes.
So,
It's an expression.
so essentially, yes. So you can just say, okay, well, case blah, and then the value that's just a value or something, and then it'll just be assigned into whatever you're
This is
assigning
one
it
of
to.
my main gripes with switches is that they aren't expressions or that there isn't like a variant that is an expression. Because so often you have the pattern where, you're trying to switch in order to set some variable. Like that
Yeah,
code just looks so ugly, when switch isn't an expression.
you just have to use 50 million ternary operators, John.
Yeah, I do love ternaries. I think anything that's an expression, I think, is better than, the thing that isn't an expression.
Just
Yeah,
statements.
exactly.
So then the next thing I want to talk about, and this kind of is going to set us up for the next half of this, which is kind of its own expansive topic, is pattern matching. So in Scala, there's this match statement, and you can match on a variable, and you can, you know, make very complicated assertions on it. I'll leave it to John because he'll be the resident expert on this, but I think actually, maybe we'll tease this because, it doesn't, I know I'm not going into that much detail, but let's leave it there. But in the next section, we're going to kind of go into more detail about how that actually works.
Sounds good. All right. Welcome back, everyone. So before the break, we mentioned we were going to chat about pattern matching. So I guess to introduce pattern matching, let's talk about what it even is. It's very similar to a switch statement. In fact, when I first was learning pattern matching, I sort of saw it as an evolution of a switch statement or a switch statement on steroids.
Right.
But what it can do is you choose an object that you're pattern matching against. And then in your case statements, you can sort of, I've heard it described before as matching on creation patterns, where let's say you're matching on a list. In each of your case statements, you can say, is this list, a single item? Or is this list two items? Or, do something else. So you can say like, was this list created as a single item, as two items, or as an empty list, or, basically any way the list could potentially be created, you can match against. And
That's okay. So this is a statement that I've heard you say before that I want to unpack a little bit, where you say any way a list could be created, which is like there could be a billion different ways you could arrive at, say, having two elements, right?
yeah,
Like you could start with zero elements and then concat a list of two elements, or insert two elements. Could I pattern match against that object history essentially? Because that's kind of what it sounds like when you say creation patterns.
yeah. So, and I think this is why I mentioned that it's not necessarily a complete definition when you talk about creation patterns. This actually all goes back to another concept called an algebraic type that I think if if we can sort of understand algebraic types a little bit, it's way easier to understand what pattern matching even is. So what an algebraic type is a type that's defined by composing other types, basically. So the classic example is like you can define a list as either empty or some item attached to a list, which are commonly referred to as head and tail.
Right.
You know, where your head is, you know, let's say your list is integers. You know, your head might be 5, and then your tail is another list. So it could be empty, or it could be a head and a tail. You know, so thus you can sort of create a list of arbitrary length, but the list itself is represented as a head plus a tail, where the tail is just another list. So anyway, that's kind of what an algebraic type is. It's a composition of types, or you know, constants even. You know, a lot of languages let you say like, you know, you can compose like some type can either be 5 or 3, you know, and that would be just perfectly valid.
That's one thing I really like to do in TypeScript is these union types.
Yes.
That feels super powerful.
Right, right. Which a union type, I think, is a form of an algebraic type. So a lot of languages have, you know, some minimal support for algebraic types. Haskell, I think, you know, famously has this like complete implementation of algebraic types that, you know, I think one of the issues with algebraic types is they're just hard to understand. I mean, at least in my experience, like I just have trouble wrapping my head around, you know, if I see some type that's like some crazy mathematical equation, like it's just difficult for me to understand. But it is, you know, it is pretty amazing. It's a powerful tool in a tool chest.
Well, this is the thing. I was reading about pattern matching, and they had a complete implementation of red-black tree rebalancing in 4 lines of unbelievably dense OCaml, which I don't even know OCaml, but it was unreal. They were like, okay, this is all of red-black tree rebalancing in 4 lines of code, and you just like kind of you just describe the way the shape of the tree should be,
Yes.
and then it kind of like is.
Right, which is why, like, and this is why I sort of detoured into algebraic types, because once your types can be represented, you know, sort of mathematically or logically, then you can have these like really powerful programming constructs like a match statement that can basically decompose a type into its constituent parts in ways that like totally feel magical. At least when I was first, you know, reading about pattern matching, they felt magical. And yeah, I think I saw the exact same example that you're talking about, where they're like, oh, is the tree a head and a left and a right? Then do this. Is it a head, left, right, and the left has a left? Then do this. And it's just this like crazy, exhaustive, you know, like set of states that the tree can be in.
Well, this is the thing, as someone who has not spent a lot of time working with pattern matching, my eyes just kind of glazed over because kind of need to understand what you're seeing. Like, oh, actually, these are comments on a recursive aspects of the structure of this thing, and so I feel like I just stopped parsing it at that point.
Yes, which I'm actually glad you brought that up, because one of my notes that I wrote down to talk with you about was like, why isn't pattern matching more widespread? Mm-hmm. And I think one of the reasons is because it's so easy to get into territory that's just very difficult to like read and understand. Mm-hmm. And I think, you know, like there's just a general issue with programming where like sometimes you're writing code and you're feeling clever and you write this like just very difficult to understand code.
Right.
And then that like annoys the rest of your team. And I think pattern matching can be guilty of sort of entering into that territory.
Right.
But what I would say is, you know, if you have a language that can represent algebraic types and can do pattern matching, and you sort of stick to the shallow end of the pool, you can really do some just pretty amazing, elegant algorithms, especially, you know, I wrote down great use cases for pattern matching. Anytime you're operating on a list and you have like some sort of recursive operation, a lot of times pattern matching can represent it very elegantly. Where you're saying like, if the list is in this situation, maybe go into this other function, or if it's in this situation, do something else. And you can do a lot with pattern matching. You can do destructuring, where you can say like, is my list, or I want to express how my list was created. Like, let's say it's 3 items. So you'd say like item 1, item 2, and tail. And you can then reference item 1 and item 2 as variables in that case block, which is a common thing you see with pattern matching, where you're destructuring your objects and you're able to like, reference fields on those objects. And it feels once you sort of grok the constructs, like it feels very elegant, because you don't have to write this code that like pulls them out into fields and things like that.
This is something I saw, and it immediately was like, wow, okay, that seems very useful to be able to do. Like, you're just, again, it's this very terse representation for doing a very powerful operation. Like, you're getting so much done in such a short amount of code. It's an impressive example of just great design. It's almost like, what's the maximum amount that I can convey in the minimum number of raw characters? It's like, so they're expressing so many things simultaneously in
Yes.
a way that's kind of ultimately very readable and understandable. So I was really amazed when I was looking at some of the examples.
Yeah, and you put that really well. Like, I think as I, program more and more and go further in my career, like I start to realize more and more that one of the most important things in programming is almost exactly what you said, like being able to express as much as possible as quickly as possible, but have it not be like just impenetrable and impossible to understand. And I think a pattern matching construct is one of those cases where you can express a lot, but it's still very easy to tell what's going on.
Right.
And there are those cases where you can kind of go off the rails and just write some crazy, pattern match, kind of like that red black tree thing. But I think a lot of the common cases where you're using pattern matching are not like that. They're just much more straightforward.
Right. And this is something that I see where it's like people like to kind of misuse some functionality, be like, look at how terrible this works. Like, I'm using this thing in like the most absurd way I can possibly do, and look, my code looks terrible. Like, and it's
Yeah.
like, well, yeah, like you can use any language construct to make something idiotic. You can
Yeah.
nest if statements 1,000 levels deep, and like no one's saying that means that if statements are bad. So
Yeah. No, exactly. So I think it's important that to distinguish like the power and ability to misuse a tool from like the actual value of the tool in a practical programming setting. And sometimes it does make sense, sort of like templates in C++. Like it's a powerful tool. It's very easy to get into territory where you've written something that's just completely impenetrable and impossible to understand. But I think it still makes sense to include something like that in the language because of how powerful the tool is and how well it works. Yeah, another thing I just wanted to mention is my first experience with pattern matching was Scala. I learned Scala maybe 10 years ago and thought it was like the greatest thing ever. But there's tons of languages that have pattern match. And I just wanted to quickly list a bunch of languages. So C sharp has it, F sharp, Haskell. Haskell has a super comprehensive pattern matching. ML, Python, Ruby, Rust, Scala, and Swift, which is exciting because Swift is a new language and it's probably also going to be an incredibly popular language. And
did you say
it
Rust
has
has
pattern
pattern
matching out
matching?
of the box. Rust has pattern matching, and I looked at a couple, Rust examples, and it's very nice. I want to dig more into Rust. Actually,
Yeah,
I haven't done a ton of Rust coding, but it just seems like a really nice language.
definitely.
One other,
Everyone loves Rust, and I feel like it deserves a real try. Got to
Yeah,
implement the sieve of Eratosthenes in Rust.
totally. One other super minor thing that we kind of touched on earlier is pattern matching is typically a functional construct. Like it's an expression versus a statement. Whereas, switch is very much like a procedural, like imperative programming construct. And I find that in my own programming, I like, I almost said I like the expressiveness of expressions, but it is kind of what I want to say. Like I feel like you can just express a more interesting, more valuable, more useful constructs when something like a pattern match is an expression. I wrote down a couple good use cases for pattern matching, or maybe common use cases that you see. We already discussed list operations. There's a really, really cool merge sort implementation that I feel like you see in Scala. If you're first learning about pattern matching, it's one of the early examples you see. Tree operations, you discussed the tree rotating. Basically anything that's a data structure and can be expressed as an algebraic type, you can do some very cool pattern matching with.
Let me ask you this. So, anytime you hear about any of these like super magical ways of doing any of these things, the first thing that comes to my mind is what is the performance penalty for all of those that magicality? So, I'm just wondering, is this worse? This OCaml red black tree, is it actually like does it have to do more work in order for it to be so compact?
That's a great question that I did not look into. I did see a blog post where a guy was implementing merge sort with Scala, and he talked about a couple optimizations, and he showed like the runtime, and it seemed pretty competitive to like a classic implementation. There's got to be some overhead, especially when you're doing things like destructuring, where I don't know, it seems intuitive that there would be overhead to something like that. But yeah, I can't give you a great answer to that question. That's a good question. Yeah, another classic use case for pattern matching is things like data classes. Like Scala has these things called case classes, which are basically value types. And since pattern matching has the nice destructuring syntax where like just as an example, you might have a case class that's like person, and you have like a first name and last name and a phone number, let's say, and you want to match against people who don't have a phone number. You can say like person, first name, last name, nil, which is like null in Scala, and that match case will be caught for anyone who doesn't have a phone number defined.
And so this is relating to the positional location of the argument that's passed into the constructor. Is that the way that it works?
Yes, yeah. So case classes, these value types, they have these well-defined constructors. They're usually like classes that are defined in one line. And yeah, so you're basically like matching on fields in the class and also like destructuring them out into variables in case you need to reference them.
Yeah, that's one thing. I could see that getting kind of unwieldy if you have a class that has many attributes to it. You need to kind of remember, because that's going to be the one thing you don't know anything about.
Oh, absolutely. Yeah, no, this is another thing that can definitely get out of control. There is usually other facilities for specifying how something can be destructured. Like Scala has this method called unapply, which is basically you can basically define how you want a pattern match against this class. So you could say, you might have a crazy expensive or crazy complicated class with like a billion fields, but you can implement an unapply method with like one argument, and then you can kind of pattern match based on that argument. So, and different languages have different facilities for like, destructuring and things like that. But yeah, you're absolutely right. Like it's definitely something that can get out of control if you have, these crazy value types. And then the last thing I wrote down was just type matching. We've all seen code where you're saying like, if this is an instance of a person, do this. If it's an instance of dog, do this. And I think, the common wisdom on that is that it's sort of an anti-pattern. It's sort of a failure of abstraction if you see code like that. But at the same time, every once in a while, you just have to write code like that for various reasons. And with pattern matching, you can match on types. And there's some big advantages to that. Like, it's exhaustive for one thing. It's probably the primary advantage. But you can also do some destructuring, which can be useful and just make your code a little neater.
Now, this is interesting. I looked at just the first pattern matching page on Scala, but does it need to be a sealed type in order for it to be exhaustive, or?
Yeah, and I think now a sealed type is one where everything has to be defined in the scope.
All subclasses are defined kind of in the scope of the abstract base class.
Right. I think you're right. I think in order for the compiler to know that it's exhaustive, the class has to be sealed. Because in Scala, you can have a trait where you can just literally like create a new instance of the trait at runtime. So yeah, in Scala it would have to be a sealed type, I believe. But obviously different languages may not have like dynamic types that can be created at runtime, in which case you can probably be more strict with the compiler.
Right. Okay. Yeah, so maybe I would challenge you. Do you have any war stories or examples of times when, or just things you can remember where you had a satisfying use of a pattern matching statement in Scala?
Yeah, sure. I mean, a lot actually. One common thing that I really like doing is having enums. I'm a huge fan of enums. It's one of my favorite features in Java, because Java has like really, really great enums. You can have like private fields on your enums and things like that. And when you're using enums a lot in Scala, especially if you're using fields on those enums, pattern matching is great because you can say, like for example, this is kind of a silly example, but say you have coins. You have like dime, nickel, quarter or something, and they have like a value on them. Then you can just really, you can sort of, like within a pattern match statement, you can sort of destructure, you can get the value of the coin very easily, things like that. As far as like real cases where I used it, yeah, I definitely
It's kind of putting you on the spot here. Maybe that's not fair. It's like,
no, that's okay.
Index all of your historical code and.
Yeah, as far as actual cases where I used it though, definitely with enums. I can't think of specific examples of enums, but also a lot of times when you're going over a list and doing something, pattern matching can be super useful.
Are you saying this is like a polymorphic list of things that you might have a bunch of abstract foos, and then there's like several different types of concrete foos in that list? And
yeah, or just a list where, you'd want to filter based on, like, say you have a list of like video game objects, and you either want to like filter on objects where some flag is set. So you'd have like a pattern match and you would just pull out, where that flag is true. And then you might be able to destructure and reference into other fields that you might need for that list or for that for loop.
This sounds like it would be super useful for things like data cleaning operations, where you need to do like some query or like against a database or something where you need to find some nested attribute that needs to change or what have you. We've used this concept of a DCR where we need to, for whatever reason, null is not a valid value for this field anymore, and we need to find all the things that where it's null and transform it. So it just seems like you could do some arbitrarily powerful like selection based on these deep nested fields. And
yeah, and to your point, I think it tends to work really well in cases where a type is just a very clearly defined thing, like an algebraic type where it's either very clearly defined or it's defined as a composition of types. Pattern matching really just works well in those cases.
How does Scala deal with serialization? Like, when types are super, or like a super strong object in a language, it seems like it can be harder to reason about like serialization and deserialization of something. And do they have a good story for that?
I guess I don't have a ton of experience with serializing stuff. They did have good libraries for just like exporting value types to JSON. Scala has this notion of value types, which are basically like these data classes where all the fields, all the field names are clearly defined and, usually public. And with something like a value type, you can create a library that just exports something as JSON, iterates over the fields. Like it can be this like sort of dynamic library. Scala also famously has XML as a first class citizen.
Right.
You can just like write XML in your code, which is interesting. But it does make it, pretty easy to like serialize XML and things like that.
I feel like JSX kind of took a page out of that book. They have, I don't know if it's fully valid XML, but you're writing some sort of, markup language inside of a JS file. So
yeah, it's nice to be able to just write like data, right in your code. Like that's one of the things I really like about TypeScript is, it just has a very thin line between like actual serialized JSON and like real code that you're writing, which I actually really like. I think that's a super useful thing.
I do think that just is kind of a game changer where the server, the wire, the front end, they're all operating on pretty much the exact same objects under the hood. So it's just like there's this whole class of errors where you just don't even need to worry about it because there's not these translation errors.
Yeah, and I think a lot of languages try to be like unopinionated about what, data you might be serializing out to. Like, we don't want to enforce that you're serializing to JSON or whatever. But it's just a huge value. I mean, for any language designer, it should definitely be like a trade-off that you need to think about.
Yeah. All right. Well, this was super awesome. I need to start working in the language or TypeScript. Come on, add matching, add pattern matching, and then I won't have to learn a new language.
That would be so cool.
But yeah, this was awesome. Well, thanks again for all of for everything.
Yeah, thank you. This was really fun. I learned a lot about switch statements. I didn't realize how little I knew about switch statements.
This is the thing. There's nothing that's uninteresting once you look deeply enough.
Yeah, totally.
All right.
Well, I will
next time.
Yeah, see you next time.